Welcome. Today I want to deal with application of Bayes theorem. An application in wireless communication is a MAP receiver. MAP stands for maximum a posterior probability. The course content is like this. Bayes theorem in wireless communication scenario will be explained, and how to calculate maximum a posterior probability, and it is compared with another probability which is maximum likelihood receiver. For this, first of all, we need to define Bayes theorem, and for defining Bayes theorem, we need to know some of the events in the sample space. Let us consider a sample space in which we have an event A, and there are other multiple events like B1, B2 and so on Bk whose influence is there on A. If we want to calculate the probability of A, we need to calculate the influence of B1 on A, influence of B2 on A and so on Bk on A. If suppose we want to calculate the intersection according to the definition of conditional probability, P of A intersection Bi can be written as P of A given Bi multiplied with individual probability P of Bi. Hence, if we want to write, if we apply the same thing to calculate the probability of A, so we can write it as P of A given A intersection B1 and P of A intersection B2 and so on P of A intersection Bk. Or equivalently, if we want to calculate P of A, we can extend it substituting intersection P of A intersection B using this equation as substituting and writing in terms of conditional probability. We can write P of A given B1 into P of B1 and so on this. So this is actually called as total probability theorem, which is denominator of Bayes theorem. And coming to the Bayes theorem, the same thing, it's just an extension. The denominator, whatever we have taken, we have written in terms of summation, and the numerator will have only the P of A intersection Bk, which is P of A given Bk into P of Bk. So this is general Bayes theorem, and when we want to apply that, and why do we apply it? Normally, probably we apply Bayes theorem to calculate a posterior probability, which is P of B given A, and also if P of A given B is known. So if one is known, if we want to calculate one unknown, we can apply Bayes theorem. Let us take it to a wireless channel. So in a binary communication channel, the name itself is binary. So at the transmitter or at the receiver, we have only two symbols, 0 or 1. So let us take the individual probabilities of P of A, 0. That means a symbol at the transmitter side, if a symbol 0 is to be transmitted, the probability is 0.1. Let us take the probability of transmitting a symbol 1 is 0.9. So these are only input considerations of the probability. And let us calculate B. If suppose 0 is transmitted in the channel, there is a chance that instead of a 0, we may get a 1. Similarly, when I have transmitted 1, there is a chance that at the receiver, I may receive 1 instead of 0 or a 1. So when I get 0 given 0, then we'll call that as a successful event, successful probability. Whereas if 0 is received instead of a 1 to be received, then we call them as error probabilities or flipping probabilities. So P, whatever P of 0 given 1 is transmitted, similarly P of 1 given 0 is transmitted is termed as error probabilities. So coming to likelihoods, likelihoods means if suppose I assume transmitter part as A and receiver part as B, P of B given A1 is 0.2 using this 0.1, and if suppose P of B given A0 is 0.8, that is called as likelihood probabilities. The name itself is likelihood probabilities, means at the receiver side probability given 0 is transmitted is 0.8. So basing on this, we can say P of B given A0 is having high probability. So the likelihood is that 0 may occur than 1 may occur because it has less probability. So this is what is just a definition of what is a posteriori probability and likelihood probability. For that, consider two events A and B, where A is a binary bit 1 or a 0 transmitted in transmission channel, and B is a probability of bit received. So here P of A0 given B and P of, that means what, the transmitter side probabilities are called as a posteriori probabilities, which are called as maximum a posterior probability map. And same thing at the receiver, P of B given A0 and P of B given A1 are called as likelihood probabilities, which are named as maximum likelihood probabilities. For example, for the same example, I have written the condition here. If suppose I calculate P of A1 given B, and if it has resulted in greater than P of A0 given B, then we decide 1 at the receiver. Similarly, if suppose P of B given A0, that is, if this is what is likelihood probabilities. So if the likelihood probability of A0 is B given A0 is greater, then we decide that 0 is received at the receiver. Thank you.